I'm 20, and my entire life, starting from my teenage years, I've been on fire for cars. Starting with the first car I got when I was 15, with my first crash and street races, and ending with today, when I dream about faster and faster cars and walking with them. Currently, I've been doing exterior car tuning for over a year now, and I have a lot to share about it. We're going to go through the main stage of creating body solution, from scanning to the production phases. All of this I have figured out through hands-on work and study, and actually turned out to be way harder than I thought. Stage 1. Scanning. To start working on any car parts, you first need to get a copy of it, and the most modern way is 3D scanning. Scanners are mainly divided into optical, hybrid and laser, and the price tag goes up accordingly with that list. Honestly, this stage isn't incredibly complicated. I've had some scanning experience before, and I did it using a very expensive laser scanner that I'm going to use again in the future. You'll see that. Even though my first scan wasn't very good, it had a lot of holes and incomplete geometry, I'm still really happy about it because I gained a valuable experience and a list of mistakes I won't make next time when I do more serious scanning. Right now I really want to buy my own scanner, even just an optical one, so I can start scanning and working with my own data. Because so far practically all the work I have done has been with other people's scans that clients send me. So with the scans we get, we need to work and actually create something. For that we need the next stage. Modeling. The key tool for modeling, of course, is the software. You can actually work in many programs, ranging from a simple CAD software to the program used by a global automotive industry. Let me tell you a bit about them. The most beginner-friendly options are programs like Automotive Fusion, SolidWorks and similar CAD systems. They are very intuitive and easy to learn, and some guys do make their car parts in them. But this software is pretty limited when it comes to automotive design, simply because it was originally built for different kind of tasks. The next level up, the more serious players, a program like Rhinoceros and Geometric Design X. These are built for surface modeling and are great fit for young design studios and people doing exterior tuning. They have a user-friendly interface that sometimes feels like CAD, lots of tutorials, and they aren't super strict or demanding about every little thing you do, which is a pretty important factor, just believe. A lot of young studios choose this sweet spot because with this program they can get excellent results for a reasonable amount of time invested in learning and working. Technically speaking, these programs are more than enough for needs of tuning shop. And finally, the highest, most elite level of software, the big boys like Autodesk Alias or ISM. These are the ones used by the global automotive industry. Practically all the giant car manufacturers choose them, and for good reason. This program lets you calculate geometry down to the millimeter and create the highest quality class A surfaces. But there is a catch. Besides the high cost, in exchange for those perfect surfaces, these programs will also suck out your soil. They are incredibly hard to learn and work with. Working on a single corner easy can take 10 minutes, and the program can suddenly reject a surface you built in any moment when you least expect it. When I was choosing my software, I just looked at cool picture on Google and the title best program. That completely flawed logic led me to Autodesk Alias. This is the program for professional design and surface modeling used at car factories. Technically, it's one of the highest and the best program for working with surfaces. And you might be asking a perfectly logical question: how reasonable is to start your career with the most complicated software? Well, let's not talk about, okay? To be honest, I had no idea. I thought that if Autodesk Fusion was so simple and friendly, Alias would be pretty similar. That was a fatal mistake. I've been working in it for over a year and I still feel very unsure of myself. There are a lot of elements that I just can't do because it's so complex. And building surface correctly with proper geometry is incredibly important, because every little problematic detail will definitely come back to haunt you in the next stage. Production. It's hard to say whether this stage is difficult or not, because it totally depends on the production method you choose. There are three main ones: vacuum forming, vacuum infusion and 3D printing. Of course, there are other more traditional craft methods, and even though they are still in demand, and even for some elite supercars, we are not going to talk about them, mainly because these methods are becoming outdated. The first two can be called the classic methods. They have been around for a long time and everything about them is well known. Vacuum forming is often used in mass production bodykits because you only need three main things: a vacuum forming machine, a sheet of a base plastic to make the part, and a mold in the shape of the final part. You put the mold in the machine, heat up the plastic sheet above it and lower it down onto the mold. Then you trim the excess plastic from the formed part, prep the mounting points, and you have a finished body part. But as I said, this method for mass production lots of identical parts, so for custom one-off tuning, people often use another method, namely vacuum infusion. This method is an absolute classic. This is how fiberglass and carbon fiber parts are made in the way we usually think of them. This process is more about chemistry than mechanics. Basically, you layer your material, fiberglass or carbon, onto the mold, cover it with special resins, create a vacuum, and end up with the finished part. Sometimes they skip the vacuum step, that's called hand layup, where you just leave the part to cure in the clean room. This method is very common, but it requires a lot of attention to the precision of the mold and to resins and how you mix them, because they are essentially what determines the quality and strength of the final part. It's worth noting that for the first method, vacuum forming, they often use molds also made of fiberglass, but with more heat resistance resins and gel coat. We can talk about how and what molds are made from in one of the next videos. And then the third, the newest method, 3D printing. There are already a lot of videos on YouTube from really cool creators making their project with this method. You should definitely check out their video, it's truly amazing. For this method you don't need any resins, ovens, vacuum pumps or anything like that, just the 3D model we created in stage 2, the plastic filament and the printer with some glue. You just load the model into the print and hit print. That's all. Well, you often have to split the model into many pieces because large printers are super expensive, so we usually print in parts and then glue them together. But this method has some big downsides, for example, print time and strength. Parts take incredible long time to print. A regular bumper could literally take weeks to print, which makes it completely unsuitable for kind of large scale production. And with this method you have to spend a huge amount of time on post-processing. You have to very carefully join and sand every little piece to make the model even remotely as strong as it would be with other production methods. Honestly, all the methods I listed have a specific set of pros and cons, and I'll definitely talk about that in other videos. Everything I told you so far is the absolutely basic foundation, without going into too much detail, just explaining how it works. Each method is incredibly vast and difficult. Over my entire time working, I've gained the most experience in the second stage, modeling. I'll definitely tell you more about that. Don't miss it. See ya.